So a function defined by two or more equations over a specified domain is called a piecewise function. Okay, piecewise function basically has more than one formula or expression to define it. So let's look at an example. We're actually evaluate the function when x equals -2, x equals 1, and x equals 0. So we have the function f of x equal to x squared plus 1 if x is less than 0. We have f of x equal to x minus 1 if x is greater than or equal to 0. Okay, so the way you read this is, okay, first, if you're plugging in something, so we're actually evaluating the function at x equal to -2, the input is -2 here. So we look at which one of these inequalities here does the input satisfy. So since the input at -2 is less than 0, we use this part of the definition. Okay, so in other words, this is going to equal -2 squared plus 1, which gives us 4 plus 1, which is 5. Likewise, let me get rid of this here. Now we have an input of 1. So is 1 less than 0, or is 1 greater than or equal to 0? Well, 1 is greater or equal to 0, therefore we use this part of the definition. And so f of 1 equals 1 squared plus 1. Actually, I just take that back. I used the wrong definition. 1 is greater or equal to 0, so it's 1 minus 1, which is 0. Okay, and then finally, f of 0. So which part of the definition does the input of 0 satisfy? Is 0 less than 0? No. But 0 is greater than or equal to 0. Therefore, we use this definition. So we get equals 0 minus 1, which gives us -1. All right, so we got 5, 0, and -1 respectively for evaluating the function at those values. All right, next here we're actually finding h of -8, h of 0, h of -5, h of 1, and h of 4, given h of x is equal to -3x minus 18. If x is less than -5, h of x is equal to 1 if x falls between -5 and 1. Okay, we're got to pay attention to inequalities here because it's less than or equal and less than. And then at h of x equals x plus 2 if x is greater than or equal to 1. All right, so once again, we have h of -8. All right, so is -8 less than -5? Is that true? That is true. That's checked. So that means we're going to use the first part of the definition. So we're going to get equals -3 times -8 minus 18. All right, so we get -3 times -8, which is a positive 24, minus 18, which is going to give us a positive 6. All right, so now h of 0, our input is 0. So 0, is 0 less than -5? No. Is 0 between -5 and less than 1? Yes, that checks. So therefore we use the second definition, which is the constant function 1. So we get 1 when when x is 0. All right, h of -5. Okay, so we have an input of -5. Is -5 less than -5? No, that's not true. Is -5 less than or equal to -5 less than 1? Yes, this is true because -5 is less than or equal to -5. It just happens to be equal to -5. Therefore, that's true. And so we get an output of 1 because we would use that part of the definition. All right, h of 1. Once again, let's check to see what happens here. So first 1 is less than -5. That is not true. Therefore, we check the next inequality. -5 is less than or equal to -1 less than 1. Oops. Is -5 less than or equal to 1 less than 1? That is not true because even though -5 is less than or equal to 1, 1 is not less than 5. 1 is not less than 1, so that's not true. Therefore, 1 is greater or equal to 1, And so we use the third part of the definition. So we get 1 plus 2, which equals 3. All right, the last one here, h of 4. The input is 4, so is 4 less than -5? No. Is -5 less than or equal to 4? Yes. And is 4 less than 1? No. So is 4 greater or equal to 1? Yes. So we use the x plus 2. So 4 plus 2 gives us 6, and that's our answer there. Okay, so here we're asked to graph the function f of x equal to -3/4 x plus 2 if x is less than 4, and f of x equals -1 plus x if x is greater or equal to 4. Okay, so it's a piecewise function, and the way I'm going to graph this is to basically graph each part of its definition and then erase what I don't need. And so the first graph we're going to see is y equal to -3/4 x plus 2, which is just a line, equation of a line. So we know it has a slope of -3/4 and a y-intercept of 0, 2. All right, the other line is y equal to -1 plus x. Now, it doesn't have to be lines, but I'm going to take advantage that there are lines. I might want to think of this line as the y equal to x minus 1 instead of the other way around. So this, I could easily recognize the slope as 1 and a y-intercept of 0, -1. Okay, so let's go ahead and plot each one of those. Okay, so I know we have a y-intercept at 0, 2 for the line -3/4 x plus 2. Okay, I'm going to use the slope of going down 1, 2, 3, and then over to the right 4. So down 1, 2, 3, and then over to the right 4. So I would have a point at 4, -1. However, I could have also have went up 3 and then to the left 4. So it would have went up 3, so 1, 2, 3, and then to the left 4. So then I would have a point at -4, 5. And then I would connect the dots there. Okay, once again, like I said, I'll get rid of what I don't need in a moment. All right, now let's graph the other line, which has a slope of 1 and a y-intercept at 0, -1. So I know I have a y-intercept at 0, -1. And then I have a slope of 1. So I would go up 1 over 1, 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 and so forth. So that one's a little easier to graph. But I have a line that looks like this and going that way. Okay, so now I know that this is the graph of two lines, but my piecewise function for x less than 4 only takes on the blue line, right? And so what I'm going to do here is just kind of draw a vertical line here at -4. Okay, so I know to the left of that, it's going to be the blue line, and then to the right of that, it's going to be the purple line. Now, I want to pay attention to this part here, okay? And so if I evaluate f at 4, then what is the value going to be? It's going to be equal to -1 plus 4, because 4 is greater or equal to 4. And so that would give us 3. And so I know at the ordered pair 4, 3, this would be a filled in circle here. And then at the other value down here at 4, -1, where it hits that line would be no good. In other words, I would have a void there, and it would be an open circle because I know it's not it's the value. It would have the order pair 4, 3, and not the order pair 4, -1. Okay, so that means to the left, it's going to be everything that's in the blue. So I'm going to get rid of the blue on the right because it's blue to the left of that line because x is less than 4 there. But then x is greater or equal to 4, and that's the purple line. And so that means I'm going to delete everything to the left of the purple line. I might have misspoke earlier. I deleted everything to the right of the red line for the blue line. But the purple line, I'm going to delete everything to the left because we know x is greater than or equal to 4. It equals the line -1 plus x. All right, and so that's how our graph would look like. All right, let's try this next example here. Determine the domain and range of the given piecewise function, then write an equation for the function. Okay, so what I'm going to do is as I imagine tracing the graph from left to right, observing what are the x and y values doing. Okay. All right, so as I'm going from left to right, I notice that the x values are being attained if I project down, right? So as I'm going from left to right there, I could see I'm achieving all these x values here. Okay, then I jump to the graph and I continue going along the graph in this middle segment here, and projecting down now, I'm hitting all those x values. And so therefore I'm hitting all these guys here. And then I jump back down, and now projecting down to the x-axis, you can see that I'm hitting all those values there. So I'm hitting all these guys. And then I stop at that 5 there because I don't have anything more to go. So from that observation there, it looks like the domain is -∞ to +5 bracket. Now what about the range? Okay, so let me get rid of the arrows here. I'll leave the blue there because we know those are all our inputs that we're achieving. In fact, let me just make this lighter here. Okay, so all those blue, that's my inputs. So now let's do the same thing here, except this time though we're going to project onto the y-axis as I go from left to right. So as you go from left to right this way, what is my graph? Where is it projecting on in terms of the y values? Well, according to this arrow here, that means it's hitting everything this way, right up to the point here. And so I could see that I'm getting everything from -∞ all the way to that point where it stopped there. And then it jumps to the graph between -2 and 2. And as I move from left to right from -2 to 2, I'm just constantly projecting onto positive y value of 2. And then from 0 to 2, still projecting onto the +2, constantly just 2 there. And then as I jump down and then 2 to 5, and I project to the y values again, I'm hitting basically all these guys. Still hitting 2 there, keeps on hitting 2 until about right there. And it looks like it finishes right about there and around 2.5. And so from this quick observation here, looks like we're hitting every y value from -∞ to about 2.5. And then looks like it's inclusive because of that point here, which appears to be at 5.2.5. All right, so that's the domain and range of this function, but we are asked to write an equation for the function. So in other words, what is f of x? Well, look at our domain, and let me clean this up a little here so we don't have to see all the scribbles I did. I'll write it all back up right now, just clear it up real quick. Basically, I have two important pieces here. So the domain went from -∞ to +5, but there's some special parts here, right, that cause divisions here, right? This part here and this part here, right? So to the left of that purple line is a line that looks like it passes through point -2, 2 with a slope of, well, let's see. Okay, so we have a point here at -2, 2. Okay, and then it looks like it has another point here at, say, -4, -4. So you need 2 points to get the slope of the line. Okay, so in that case, or visually here, we know we went down 2 into the left. Sorry, down 1 into the left 2. So that looks like that line has a slope of -1/2. Okay, and so what would the equation of that line be? So y minus, well, let's check that point at -2, 2. So we'll use the, what is it called? The point slope form of the line, which just looks like this. Okay, and so I'm going to use the point -2, -2. So I have a -2 for the y1. And my slope appears just from going down 1 into the left 2, it was -1/2. And then x minus x1. What is x1 here? -2. Okay, so we get y plus 2 equals -1/2 x. And then technically that's a plus, so we get -1 there when we distribute. Okay, so it looks like my function f of x looks like -1/2 x minus 1 if x is less than or equal to -2. And then it's the stuff between -2 and 2, and notice the open circles there. So that means it's going to be if x is strict inequalities there. In other words, it's falling between, x is falling between -2 and 2. So we'd say x, -2 is less than x, and x is less than +2. And it's constantly the value 2. It's just a horizontal line of 2. All right, and then we have our next line here, which passes through the point 2, 0, and also the point 5, 0. No, not 5, 0, but 5, 5. In fact, let's use an easier point there because I notice it hits the grid there at 4, 2. Okay, it passes through 4, 2 as well. So how much of a rise is that from those 2 points? It's a rise of 1 and to the right of 2, so it looks like the slope there is 1/2. All right, so then we could use that information, and that happens to be useful information to get. We could use the slope intercept formula in to find the equation of that line. And doing so, we would have y minus 0 equal to 1/2 times x minus 2. So we get y equals 1/2 x minus 1. And so it looks like this is 1/2 x minus 1. If x is greater than or equal to 2, but then it doesn't go beyond 5. So because our domain is what? -infinity to 5. So then we would write this as +2 less than or equal to x, and x is less than or equal to +5. And that's our piecewise function. All right, so the goal is just to identify the equation of each of those lines and piece them together. That's it for this video.